It's just a science project.
Silent breed is people!
A doctor friend once said the same thing to me. Frankenstein was his name.
It's alive! It's alive! It's alive!
That sounds like something out of science fiction.
Please explain to me the scientific nature of the whammy.
We live in a spaceship, dear.
So?
Yes, science!
Program complete. Enter when ready.
Hello and welcome to episode 226 of Science on Top. Today is Sunday, the 15th of May, 2016. I'm Ed Brown and I'm joined by Penny Dumsday.
Hi.
And Lucas Randall.
G'day.
A big show today. We'll be talking about how sea level rise has already claimed 5 whole islands. We're talking about earthquakes going on under Mount St. Helens. And a beautiful new jellyfish discovered in the Marianas Trench. But to begin with, Lucas, we haven't talked about exoplanets for a while.
Oh, really? What?
No, not really.
Sure?
And it's mostly because they're fairly dry stories. We found a planet orbiting another star X number of light years away. Sometimes there'll be a bit more information, like we know this planet is made of diamonds or glass.
I remember that planet.
Yeah. Or it might be exactly like Earth in the sense that it is a planet and completely different in every other way.
An M-class planet?
That story seems to come up quite a lot, actually. An Earth-like planet that is uninhabitable and made of gas and millions of light years away. But there was some exciting news announced this week from the Kepler mission. It's a further 1,284 more exoplanets have been confirmed. The sky is full of planets, Lucas.
Yeah, pretty much. And we've inferred this already from what we knew. It's really, to be honest, it was no surprise whatsoever. It was unprecedented in terms of the number of planets that were all announced at once. But this actually comes from data that Kepler had collected prior to its second of 4 gyros going down, which basically meant that it could no longer aim itself properly. And it's since been, which we've discussed before, it's embarked on a second lease of life where they figured out how to use the sun in order to aim it, which was really, really cool because it has been, an amazing scope. So it's still limping along, so to speak. It's still collecting data, but this data was actually from prior to its extended mission, beginning. And basically they've just announced all these planets that have come out of the analysis of that data. And really that's something else to consider with this particular instrument is the immense amount of data that it collects. And the manner in which it collects it is really quite astounding. This has really been a planet finding, demon. It's just it's done its mission so incredibly well. It's just stunning.
It's a great feat of engineering to create something that can accurately spot the tiny dimming of light from a star thousands of light years away and do it so accurately and trace it that you can then glean from that its orbital period, if you see it happening several times, at the size of the object, its distance away and all of that. And to do it for so long, I'm trying to find how long Kepler's been up there, but it's been a good 4 or 5 years, I would say.
Yeah, it was launched in 2009.
Wow.
I'm not exactly sure when the mission began, but that's how long it's been up there. And I guess it's worth just considering. I mean, we said at the beginning of this story that, it's not that exciting because it's become a little bit routine. But how awesome is it that it's become so routine? It was only 20 years ago that we confirmed the first exoplanet beyond our solar system, which was a super Jupiter or a hot Jupiter. That's amazing that in such short time we've gone from, oh my God, we've confirmed there's one planet outside our solar system to here's another 1,200 or so whatever it was. So it's pretty incredible.
The total up now to 3,264 confirmed planets.
Yeah.
With another 4,696 candidates. They need more information to confirm it, but it's
this is actually a byproduct of the way that Kepler works because it uses the transit method in order to identify things. It basically looks, as you mentioned before, it looks for a slight dimming of any star, and if it sees a dimming of a star, it gets marked as a candidate. It's like, okay, we need to see the same dimming again, and when it's watching a star, it measures it in such such extraordinary fine amounts that they can actually track. If you see it on a graph, you can actually see the planet as it comes around the limb of this star, and then because it'll be a slight dimming, and then a much greater dimming as it actually makes it across the face of the star. Then you have that that amount of dimming occurring for most of the transit, and then it starts to dim again. So it's a signature. It's something that gives it away that something's gone in front of it. And what they need to do in order to confirm it is they need to see it again. And because the signature is very specific, they just look for the same specific transit again. And what they could potentially find is, okay, we've seen another potential transit event around this star, but it wasn't the same planet.
Yeah, it was a different planet around the same
exactly.
star.
So they could find, multiple planets in any one system, and it really just comes down to the orbital period, because, of course, a transit event occurs when we're looking dead on along the plane, or pretty close to along the plane of the planets orbiting around that star, because they all tend to orbit on the same. If imagine a plate or a disk wrapped around a star, they all tend to, most of the planets will tend to orbit around that same plane. And I say most because there's, as we know in our own solar system, there are other objects like dwarf planets and, our Kuiper belt objects and things from the Oort cloud and all sorts of stuff that will orbit in different and erratic and strange ways. But things that form out of the same disk that forms the star will be on the same plane unless they've been knocked out for some reason. So if they see a second one that has a different signature, okay, now there's two that they need to confirm by a further observation. And some of these, transit events might be 70, 80, 90, 100 or more years apart. So if you look at the number of unconfirmed ones, they're ones that we may never confirm with this instrument because they could have very long transit events. However, the closer the object to the star, the basically we can, as you mentioned before, we can infer from the signature whether it's something that's very close or something that's very, very far away. So something transiting that's much, much further away will tend to have, just because it is closer to us in relative terms, it will have a slower transit across. Something that's very, very close will have quite a fast transit across. So it also, in addition to giving us a signature to look for again, it also gives us some telltale idea of how long we will have to wait before we see it again.
Yeah,
so they can, watch it again. But yeah, I mean, it's kind of cool that it's become this routine that we've now got over 3,000 confirmed planets from one instrument alone, which is over 2/3 of the known ones out there. And of course, this instrument only looks for transit events. It doesn't use any of the other ways, the cunning ways that they've found to identify things. So,
which I think is even more extraordinary, that we've found this many planets that just happen to have their orbital plane on the same line of sight from us. And that there could be ones that are tilted on such an angle that we never see their planets transit. We have no idea of knowing how many such planets there are.
That's exactly right. And then we're looking for other ways, like the wobble method, for example, where you see planets will be going around their star and they're slightly tugging on it, so the planet will tend to wobble from side to side. But yeah, you're right. I mean, it's amazing, but that's also a function of just how many planets we do believe are out there, because we're starting to find that planets are incredibly common, almost to the extent that we, years gone by, we used to think that maybe planets are a little bit rare and that not every star has them. Now we're starting to think that it's sort of the majority of stars that would have planets, which radically improves the chances of finding planets around things. But it also means, perhaps the chances of life are that much higher, because this is one of the parts of the Drake equation is how many stars are there and how many of those stars have got planets around them. Yeah. So you add them all together, and that gives you a statistical reference to how likely it is that there's life out there.
And we've got to keep in mind that Kepler is probably going to run out of fuel, I think, in sort of middle of 2018. But there'll be more satellites that are going to be hunting exoplanets going up soon. I think the TESS, the Transiting Exoplanets Survey Satellite, goes up in 2017. And then there's another, the James Webb, of course, in 2018. And both of these will probably be a much more accurate and better way of finding planets outside our solar system.
Yeah, and this, as far as missions go, this has done exactly what it was designed to do. And as I mentioned before, it's now on an extended mission where not only is it looking for stars around planets, but it's now being also tasked to try and find, rogue planets that are not attached to a system at all that are floating around, which is really, really cool. And it's one of the things I really love in so many NASA and JPL, stories is just that ongoing, okay, what can we do now? How can we solve this problem? Well, we've talked about it when we were talking about the Martian and stuff like that. It's just that spirit of making the best of it. This has happened now. How can we use the mission in ways that were just never intended to continue extracting science, which is just awesome.
Well, we've got this thing up there. We might as well try and get something out of it until everything is absolutely used up.
It's such a shame we didn't get more out of Philae. There was a lot of hopes that once they got a confirmation that it's like, I'm here, I'm just really, really tired. It's like we're hoping
I'm in a cave.
I'm probably lying on my side in a big shadow. But that would have been awesome if we got some more data back from that little guy. But wasn't to be.
Philae, for those who don't remember, is the little probe that landed on a comet. And the Rosetta spacecraft, its mothership, is still orbiting that comet. But that's all well and good for things out in space. But there are dangerous things happening on Earth. And Penny, last night, I settled in for my weekly...
I was wondering what you're going to say there. It's like, dangerous thing happening on Earth. Penny, what have you been up to?
What? I didn't do anything. I was just listening.
So you say. But last night I settled in for my weekly bath and I was perusing, as I so often do, the latest issue of the Daily Express, the UK's second most popular racist newspaper. And as you can imagine, my shock and surprise when I turned the page and this headline leapt out at me. Scientists warn America's deadliest volcano is recharging for eruption amid quake swarm.
Oh my goodness.
So on the basis of these warnings from the scientists, Penny, I can assume the surrounding areas have been evacuated, the National Guard is on standby, and FEMA at the ready, are they?
Yeah.
Nah.
I still think it's an interesting thing. Like, I think maybe the what was that paper called? Not the Daily Mail.
Oh, the Daily Express.
The Daily Express maybe talked it up a little bit.
I would never read the Daily Mail.
Like nothing in that headline is really truly 100% incorrect. And yet somehow it gives a very misleading impression.
I don't know if any scientists have been warning about it, have they?
Well, true. In fact, one of the articles that I read in Scientific American, the author is actually so excited that Mount St. Helens might erupt. And her whole article is basically, it's probably not going to happen soon, but I wish it would. And then down at the bottom, they've got their little disclaimer: these views are not necessarily those expressed by Scientific American.
Is it in like small writing as well?
Oh yeah, tiny writing.
Oh no.
The views expressed are those of the authors and not necessarily those of Scientific American, which is another way of saying we don't really want it to explode and kill people.
Yeah, because presumably when it explodes, things will be fine. It's a pretty well-studied, well-known volcano, but
yeah, I think we'd have some warning.
Yeah. Anyway, so what's been going on? Why is this even a story? It turns out there have been seismic swarms, but they're not as exciting as you might think. They're just little earthquakes have been happening. So what happens when a volcano erupts? The magma or the molten rock underneath can come out, or ash and whatever comes out. But it takes a bit of time to recharge. So the magma chamber needs to refill, and that essentially means that magma needs to well up through cracks and get back up into the volcano. So this happens in sort of bursts, which are accompanied by little swarms of earthquakes. So yes, it's a seismic swarm, but all the earthquakes are really small. You need a seismometer to feel them. It's not like the Earth has been rocking. And it doesn't mean that the volcano is just going to erupt tomorrow. So if you have a look at the data, there were big seismic swarms in 1990, sort of 1995, 1998, 99, but the volcano didn't erupt until 2004. So there's 5 years between a big recharge and an eruption. So, yes, we've been warmed.
We can wait another 5 years.
But we can probably wait another 5-ish years.
Yeah.
Anyway, I still like it. One thing that I really hadn't ever thought of is when you see all this seismic data and stuff, you just think all these neat little numbers or dots on a computer screen. But it had a picture of the seismic stations and they get covered by snow. People need to maintain them. Like, it's actually quite a physical job. Yeah, a dangerous physical job. Which, yeah, in this age of data, you sort of assume everything's just done by a satellite, but not so.
That's true. Yeah, no, you need on-the-ground data recording. And you were talking about those little earthquakes that you can't really feel.
Yeah.
I think they were ranging between the smallest quake that they detected was 0.5 on the Richter scale up to, well, whatever the current scale is now. It's not Richter anymore, is it?
Oh, I can't remember.
Yeah, but that went up to 1.2, and humans generally can't feel below about a 2.5 or something. So they're really slight tremors that we're talking about here. But the 1980 eruption of Mount St. Helens, I think, killed 57 people, I think, and caused heaps of damage to property and things. So,
and, like, I can totally get I really wish something exciting would happen. But, yeah, you never know when something exciting is going to turn into something quite tragic. So, yeah.
Well, there's that. And I don't know if Mount St. Helens is near any flight paths or whatever, but we can all remember the traffic disruption when Eyjafjallajökull erupted in Iceland a few years ago and grounded all the planes. Anyway.
Oh, yeah.
Well, from geology to geography. And one of the things we've been hearing from climate change scientists for a long time is that as sea level rises, some countries could be lost underwater. Countries like the Maldives, Seychelles, Solomon Islands. Great risk of being destroyed by climate change, and not in the distant future either. This week, research published in the journal Environmental Research Letters shows that at least 5 reef islands in the Solomon Islands have been lost completely to sea level rise. Lucas, we've had anecdotal evidence of islands shrinking, I guess, for some time now. This is the first solid scientific evidence of it happening, right?
Yes, it's the first scientifically documented evidence, and it comes from a number of sources as well. They haven't just looked at, okay, what's going on with, comparing photos or anything like this. They've used a whole lot of lines of evidence to put this together, and particularly to try and understand what factors are involved here in the Solomons. The Solomons have been, well, they've described as a hotspot for sea level rise for quite some time, a couple of decades, and basically the sea level there has risen at about 3 times the global average, which is about 7 to 10 millimetres per year in this area, which is compared to the 3 to 5 per year around the rest of the world. So that's partly due to natural climate variability in this particular area, because obviously there are other factors at play which will cause the sea water to increase in temperature in any given area at any given time. Things like local effects, El Niños, and that sort of thing. So over this period of time, they've had some of these local effects. So you could argue, okay, well, so these islands haven't been lost because of global warming. But the 2 factors at play here are these local things have occurred time and time again. There's something that they're able to map back using traditional knowledge from the communities that have lived here, radiocarbon dating of trees and other information they're able to get out of the landscape, so that they know that these things have been happening, over and over again. In fact, they do, throughout many places in the world for all of time that we're able to measure. But what has changed is the baseline. Obviously, the sea level is rising at a rate that is causing these islands to erode very, very quickly. They've found that wave action has a particularly important role to play in this as well, because the erosion caused on some of the islands that have experienced exactly the same sea level rise as other islands has had a much greater effect on their coastlines and caused them to erode away. So the takeaway message from this is, They've used multiple lines of evidence to figure out what's going on and why this is different, because some of these islands, for example, had quite dense vegetation on them, vegetation that's been there for at least 300 years, and they've been wiped out in a very, very short time. So they know this is unusual, and as I say, they've used local knowledge and so forth to back that up. But what is important is this is a bit of a litmus test for what is likely to occur elsewhere in the world. The worrying thing is, if you take the sea level rise that's occurring there right now and compare it against what is predicted even with the very lowest conservative forecasts based on sea level rise in the second half of this century, this is exactly the type of sea level rise we expect to see globally. So it doesn't take long for these islands to be wiped out. And in this case, there are tens of thousands of people who have had to move, basically completely uproot their lives and move to other areas. And that's spread over lots of different little communities and so forth. But there are some communities that have been there for a very, very long time that now have completely gone. These people have had to scatter to the winds. They've gone to other, family and tribes and so forth around the place, and effectively try and start their lives again.
Yeah.
And we know that the Pacific Islands particularly are very, very vulnerable to sea level rise. And unfortunately, this is just the beginning, and it's really quite scary. And it really shows how governments and certainly the governments of the government of the Solomon Islands are putting together a response to this as how they're going to handle this in the future, because obviously they're very much at risk.
Yeah, and it's also, I think, interesting. Some of these were reef islands, and that's one of the trouble also in the Maldives, where they're mostly coral reef islands, is that as oceans, the acidification rises, that kills off the coral as well. So you also get the islands collapsing underneath you as well as the water rising up. So it's kind of a double-edged sword in some ways, and just means we just need to do what we can to... I think... Even more disturbing, I think, is in this article about the Solomon Islands, they're not just talking about how do we stop global warming, how do we slow it down. They're just talking about adaptation. Yeah. How do we make it do with what we can once this happens? Because it's inevitable now, in many ways, that something is going to happen. This is going to keep on getting worse.
Well, I guess that's why they get rid of all the people from the CSIRO, because it's, it's a really...
Don't need them
anymore, we don't need them.
Yeah.
Don't need you. Yeah, you can
well,
go do
we don't have
else.
the Solomon Islands. We don't need the CSIRO to monitor. Oh, no. That's another morbid train of thought that I went down there.
Yeah.
We need something. We need something colourful to end on.
This is getting depressing.
Something happy. Let's think about something happy. It doesn't matter what the sea level is.
Penny, cheer us up then by telling us about the jellyfish with bright yellow gonads. Let's end on a winner.
To appreciate this jellyfish, you really need to have a look at the footage, which is
kind of cool.
Kind of cool. When I first saw it, I thought it was an animation, but it's real footage, and you can watch live footage. It's provided by the National Oceanic and Atmospheric Administration, which I guess is NASA's little poorer ocean cousin, and it's exploring in the Marianas Trench, and in specifically a place called the Enigma Seamount. So this is all
Why is it called that?
Because I don't know anything about it.
It's like we scripted that.
But we didn't. That was completely ad lib. Anyway, so it's a really beautiful creature, and it has these bright yellow features, which are probably gonads, and red features, which are probably its digestive system. So it's interesting that it would have such nice colours living so far. Yeah,
and that is one of the things that they talk about on the NOAA website. I only just realised that NOAA sounds NOAA, which is ironic for ocean. Anyway, and there is an article on there about why a lot of the fish they see, at the top is all colourful, but as you get down to about a mile down, they're almost all uniformly brown, grey, or ghostly white. But the really cool thing about this is, this is the Oceanos Explorer, a boat that's sort of parked above the Mariana Trench, and they're sending these unmanned vehicles down, and you can follow you can see the camera live view on the net on the website. It's really cool. It's quite
hypnotic.
It is. And it's just interesting to see as they go by and they find these weird little coral-like things, the little small creature, plant-like things on the bottom of the trench, which is really cool that we can now do this in one of the most remote places on the planet. It's like the deepest part of the planet, of the ocean. It's great. So we'll have a link to that in the show notes, and I highly recommend you all jump on. Time zones might be an issue for our American and UK listeners, but check that out and have a look at the website as well. The NOAA website. It's got lots of really interesting articles and stories and footage and photos and all that. I highly recommend it. But I think that just about wraps up the show. We'll have all the links to the stories we talked about today at scienceontop.com/226. And that's where our social media links are as well. You can email us, feedback@scienceontop.com. And please, please, people, stop what you're doing and go and leave us a review on iTunes right now. Go on. And thank you once again, Penny and Lucas.
Thanks, Ed.
Thanks, Ed.
This episode was edited with artistry and elegance by Marcos Benemu. And thank you everyone for listening. We'll be back again next week, putting science on top of the agenda. Join us then.
A university in England says drinking champagne every week may help delay dementia and Alzheimer's disease. They say only 1 to 3 glasses a week, not a day, a week, can be effective for your health.
It's fantastic news.
No, it isn't. No, because there's a big issue with that study, aside from the fact that if you are celebrating with champagne 3 times a week, your standards for celebration need to be much higher. Champagne is acceptable on New Year's, Valentine's, birthdays, and if and when Henry Kissinger dies, and that's it. That is it. That is the full list. But the bigger issue is that study was performed on rats. And how do you not tell people that? The truth is, while studies performed on rats and mice are undeniably useful, their applicability to humans can be limited. The overwhelming majority of treatments that work on lab mice do not wind up succeeding in humans, which means 2 things. A, we shouldn't rush out to report rodent results. And B, during lab mouse funerals, when they say, at least he didn't die in vain, most of the time they are lying. I know it hurts to hear that, but them's the breaks, mouse.